Trigonometric compound angles part 2. There we are. There is our formula which we derived in part 1. So there's a bit of practice. All we do is apply the formula. There are lots of exercises in this video where we just slot straight in. There's P, there's Q, therefore we put PQ, PQ, and there's our expansion. Same with 60 minus 45. There we are. Both directions. Be careful of this, because it's often the case you end up being faced with something which looks pretty complicated, but then you say, hang on, there's a cos plus sine pattern. Yes, this is the cos compound angle formula. We just need to go back the other way. So there we are. And if you try it in your calculator, that one, you'll get 0. So here's a few confirming reduction formulae. 270 minus alpha, think of that as a nudge. Well, that's into the third quadrant where cos is negative. Attached to 270, it goes to sine. Negative sine alpha. But let's do it by the compound angle formula. There we are, 270 minus alpha, a minus b, I've put into the formula. There's cos of 270, there's sine of 270. How did we get those? Well, calculator. Even though you're told not to, there's no harm in doing it. The thing is, you must show you're working. There we are, without use of a calculator. We recognize cos plus sine. Yes, cos compound angle formula. There we are. 70 minus 10 degrees, 60 degrees. Cos of 60 is a half, because it's a special angle. Here's some exercises to do. Putting into the formula, recognizing to go backwards, proving some. Bit more into the formula and simplifying, finding the value, and then a bit of application. So let's look at them. Good idea. Pause as you go and try them yourself. Cos of x minus y, formula. Bit of a space problem there. Right as a ratio of a single angle. So we're now recognizing the cos plus sine pattern. Oh, cos of b minus c. Cos plus sine, cos of theta minus beta. Cos plus sine, oh, cos of 35 minus 25. Give you cos of 10. Cos plus sine, give you cos of 80 minus 10, cos of 70. Cos plus sine, same thing, cos 10 minus 80, negative 70, fourth quadrant where cos is positive, so there we are. If we could have written that as cos 80, cos 10, sine 80, sine 10, and then we would have had 80 minus 10, ending up with the same result. Another one where it ends up with being a negative value. This time we end up with cos 45, a special angle. Proving. Put into the formula cos 90, 0, sine 91. Into the formula cos 180, negative 1, sine 180, 0. A good way to remember these is just by the graph. I'm sure you can picture the graphs, and if you think of cos, you start at the top and it goes down to 0 and then down to the bottom. Oh yes, negative 1. Sine of 180, the sine graph starts as 0. At 90 degrees it's there. Then it returns to the axis at 180 degrees, 0. Cos of 360 degrees, well, it's the same as 0. It's starting at 1. And sine of 360 degrees, same as 0, starting at 0. So there's your 0, there's your 1. Theta plus 90 degrees, beware. Do you notice that we have a plus addition instead of subtraction? Now at the moment we only have a formula for subtraction, but we can easily solve that by writing subtract negative 90. There we go. Subtract negative 90. And when we slot it, that means theta negative 90, theta negative 90. There we are. Negative 90, same as 270, 0, negative 90, negative 1. There we are. We end up with negative sine theta. Without using a calculator. Into the formula, special angle. Cos of negative 45 again, fourth quadrant, cos positive. Now here's a hint for you, of course. Whenever you get this where it says without using a calculator, you need to say, well, how can I use the known special angles 30, 45 and 60 to get there? So the hint says use 60 minus 45. We could have used 45 minus 30 as well. You'd end up with the same result. So therefore I'm going to write that as cos of 60 minus 45. Cos plus sine sine, our formula there. Put in our special angles. And that gives you root 2 over 4, root 6 over 4. So therefore a common denominator of 4. Sine of 75? Well, this is a co-ratio. Think of that. Sine of 75 is equal to cos of 90 minus 75. Cos of 15, we have just found it. So that sine 15 equals that. Now it says use your answer from A, which means the root 2 plus root 6 all over 4 we can use. So there we are. Cos of 15 is root 2 plus root 6 over 4. We actually found that anyway. Cos of 15 there. Now, why am I finding cos of 15? Well, I can't find sine of 15. So if I find cos of 15, I now have the x, the r, because remember cos is x over r, so I now have the x, I have the r, which means I can use Pythagoras' theorem to find the y. Here we are. Y squared, r squared minus x squared. So it's going to be 4 squared minus, and then that two-term expression squared. Now be careful. Square the first term, multiply the two together, and double. So multiply the two together, and you get root 12, and there are two of them. Square the last term. When you square the square root of 6, some may end up with the square root of 36, but that's still 6. That becomes 8, and 12 is 4 3s, so the 2 comes out. Square root of 4 comes out as a 2, with that giving you 4 multiplying, and there we are. So now we know y squared. Therefore, sine of 15 is that, which we had to prove. Y squared is that, therefore y is the square root of that. I'm very aware of the fact, I hope you are too, that whenever you have a square, when you get rid of the square, you need a plus or minus. But this is an acute angle, first quadrant. Hence, give cos of 75, well, there's sine of 15. Co-ratios. Different sort of question now. Sine alpha equals 3/5. Think carefully what you've been told. What is sine? Y over R. Cos of beta is 5/13. What is cos? X over R. So we've been given the Y and R, we've been given the X and R, Y and R for alpha, X and R for beta, so we must make sure we don't confuse those. So sine of alpha, 3/5, Y over R, 3/5, Y3, R5. Now notice what I've done is I write a suffix, Y alpha equals 3, R alpha equals 5. And there's the diagram. You're often asked to show a diagram, so you must just draw it in the quadrant. There we are. By Pythagoras' theorem, x has to be 4. Now let's go to the beta. We know that. Now that's also a Pythagorean triple. Remember the 3, 4, 5 triangle. This has one too. There is what is the 5, 12, 13. But we'll get there. X, 5, R, 13. So there we are. X value 5, R value 13. By Pythagoras' theorem, Y beta is equal to 12. So, now we have the XYR, XYR. So now we're told to find cos of alpha minus beta. So we do. We just expand it. There we are. Cos alpha, x over r, x over r. So it's x over r for alpha, x over r for beta, y over r for alpha, y over r for beta. We know all those values, so we substitute. And there we are. Common sort of question. Let's do another one. There's an extra complication here that we need to look at. Sine theta is 3/4, and theta is between 90 and 360. This says sine is positive. So that can only mean one thing, because theta is not an acute angle. This can only mean that theta is in the second quadrant. Sine of theta is negative, which tells you third or fourth quadrants, but cos, this is phi, cos of phi is positive, which means sine negative, third or fourth, cos positive, fourth. There we are. Sine theta is plus, and theta being between 90 and 360 means theta is in the second quadrant. There we are. Which means y over r is 3 over 4, which means we have y3 r4. Don't think this is a 3, 4, 5 triangle, because it's r that is 4. So we use Pythagoras' theorem. There's 3, there's our 4, and we calculate by Pythagoras' theorem. Square root of 7. Luckily we've drawn the diagram, because watch what happens next. Oh dear, this is a negative x value. Second quadrant, to the left, x is negative. You will lose more than half your marks in a question if you don't pick that up. So there we are. Let's now have a look at phi. Sine negative, cos positive, which means quadrant 4. That's where sine is negative and cos is positive. There we are. This tells us y is negative 1, r is 4. Why not 1? Why 1, r negative 4? Quite simply because r is always positive. we are. There is the r value there. There is the y value there. Pythagoras theorem, r squared minus y squared, so it's 16 minus, and when you square negative 1 you get plus 1. 16 minus 1 square rooted. There we are. So we now have our x, y, and r for theta, our x, y, and r for phi. So now we have to find cos of theta minus phi. Expand it. There we are. There's our definitions. Slot in our values that we need. And it simplifies that. Both over two terms, both over 16. We can multiply these together because they're both inside. And 7 15s give you 105. So it's negative square root 105. Minus 3. Unlike terms, you cannot add them, so we're not going any further. Here are 3 examples to do. Try them yourself, then you'll go through the answers. And let's look at the first one. Now we're going to have to find the x, y, r. We'll have xa, ya, and ra. So there we are. Xa is 7, x over r, ra is 25. Therefore ya will be 24. 25 squared minus 7 squared, but this is a Pythagorean triple, 7, 24, 25. Angle B, x over r, so therefore x is 3, y is 5, and that's pretty straightforward. Sorry, r is 5, I think I might have said y is 5. Y is equal to 4. Now I'm finding cos of a minus b. Well, there we are. Let's expand. There it is there. xa over ra, xb over rb, ya over ra, yb over rb. There we are, our answer. Number 2. Here we go. Quadrants again. Sine is negative. B is less than 270. Well, sine is negative in the third and fourth, and this is less than the fourth. This tells us third quadrant. This here tells us sine positive, and alpha is between 90 and 360. Got to be second quadrant. But let's have a look. A is in the second quadrant. Therefore x is negative. B is in the third quadrant. Both x and y are negative. So there we are. Y over r. So ya is 4, r is 5. 3, 4, 5 triangle, x is 3, but second quadrant x is negative. Negative 3. B is negative 5. This has to be positive r. R is always positive. Use Pythagoras theorem, or see that it's a 5, 12, 13 triangle, and we work out that x is 12, but it's third quadrant, and x is negative, so therefore negative 12. Cos of a minus b, there's our expansion. Slot in your values, and there's our answer. Let's have a look. A and b are acute. Cos A is 1/3 and B equals 90 minus A. Well, if you remember your work, if you compare 90 minus A to A's x and y values are swapped to give 90 minus A. But anyway, let's have a look. XA is 1, RA is 3, cos A, x over r, 1 over 3. Ya, square root of 3 squared minus 1 squared, which is square root of 8. So that should be an equal sign. Equals 2 root 2. Cos B is equal to cos of 90 minus A. Isn't that useful? So cos B, we need to know cos B is cos of 90 minus A, which is sine of A, which we can find because we know the values for A. Sine of B is sine of 90 minus A, because there's B, which gives you cos of A. So now, in our expansion, cos A cos B plus sine A sine B, that means cos A, and we found that cos B is equal to sine of A, so I have a sine of A there, plus sine A sine B, so sine A, and we found that sine B is cos of A, so there we are. We can now slot in our values, and there is our answer.